the next topic we are discussing the principle of superposition of wave. The principle of superposition of wave. See, let us, we are considering this is a particle. What is considered as a particle? Okay, this is the particle. Now we are considering one wave. This is the wave. This is a wave. Now this wave having crest and trough. Crest and again here is the trough. See, this wave is traveling. This is the direction. Now particle is there here the position. If the crust is instant on this particle, the crust is instant on particle, this particle is moved in a upward direction. The move in a upward direction. If trough is instant on this particle, when the trough is instant on a particle, this particle can be moving in a downward direction. See again, this crust can be instant on this particle. Again it's moving in a upward direction. And when this trough is instant on, again this is a particle is moving in a downward direction. That means the particles are moving in a up and down. That means it is an oscillations are made by a particle. This is the wave. Now this is the first one. We consider the another wave. See, this is the another wave. Here we consider the another wave. So this will be the another wave. Now another wave. This wave also having the crest, trough, crest and trough. Again this crust is instant on this particle. Again this particle is moving in a upward direction. And this trough is instant on this particle. It's moving in a downward direction. Again it's a vibrating. The vibrating means this first wave of a displacement we consider the y1, and the second wave of the displacement we consider the y2. Therefore, if two waves of displacement y1 and y2, and their resultant displacement y is equal to y1 plus y2. That is the sum of vector. The sum of vector y is equal to y1 plus y2 plus and so on. See, this is the resultant displacement. See, what is the principle of the superposition means? See here, it is stated that two or more waves are simultaneously impressed on this particle. The simultaneously impress is nothing but effect on the particle of the medium, and the resultant displacement of any particle is equal to the vector sum of the displacement of all waves. The vector sum of the displacement of all waves is nothing but the resultant displacement y is equal to y1 plus y2 plus and so on. For example, if n waves having displacement, right? That is y is equal to y1 bar plus y2 bar plus y3 bar plus and so on plus yn bar. See, this is the formula of a superposition of a wave. See, observing here. See, what did we say that? Observing is the when are two or more. This is the two or more impressed on a particle. See here the particle. Impress is nothing but effect. See, the impress is nothing but the effect. The particle in a medium. The resultant displacement of any particle is equal to sum of vectors of the all waves. Is called the principle of superposition of wave. See here, the next topic we are discussing about the reflection of wave. See, let us consider Let us consider plane boundary surface. It is separation of a two mediums. This is considered the medium 1 and this is considered the medium 2. This is the medium 1 and this is the medium 2. This is called as the boundary between two media. Between the two media. See, this is the plane boundary surface of the separation of a two mediums. Now we are considering this is a normal. What is considered this as N is nothing but normal. Normal is nothing but is called as a perpendicular of a plane boundary. Now we are considering this is on a wave. This is called as the incident wave. What is called this as incident wave? Incident wave. Now this wave is incident on a boundary surface. Now it's making some of the angle with a normal. Is called as the angle of incidency. Is called as the angle of incidency. And here the sum of the part of the wave is can be returned back in the same medium. Returned back in the same medium. And the partially the sum of the wave can be refracted. Is enter into the another medium. Now its here angle is considered by the R. The normal and refracted ray is called the angle of refraction. This is called the partially refracted wave. Partially refracted wave. Now so which is the back into the same medium is called as the reflection wave. And this reflection wave, the made an angle with a normal is called as the angle of reflection. So this is called as the angle of reflection. See, this R is called as the angle of refracted. Angle of refracted. And now this I is called as the angle of incidency. Angle of incidency. See, now we are observing when a light is traveling, the wave is traveling in a first medium, instant on this plane boundary, the some part can be returned back. Some part can be returned back in the same medium. The some part can be enter into the another medium. Now which is the enter into another medium is called the refracted wave. The which is the back in the same medium is called the reflection of the wave. Now it's made of angle is called the angle of reflection and angle of incidence angle. This is called as the reflection of wave. What is called here the reflection of wave. Here the one condition is there, angle of reflection, angle of incidency. Angle of incidency I is equal to angle of reflection. Angle of reflection is denoted by a R. That is equal to I is equal to R. Angle of incidence is equal to angle of reflection. This is called as the reflection of wave. So next topic we are discussing reflection of a wave pulse from a boundary. The reflection of a wave pulse from a boundary. Before we see the reflection of a wave. The reflection of a wave, the wave is instant on a boundary surface and the some part can be returned back in the same medium. The some part is observing and entering into the another medium. That is the reflection and refractions are we can already see. But here the first one, the wave pulse is nothing but the first one, the rigid or fixed end reflection. The total we have two. The first one is the rigid or fixed end reflection. The second one have the free end reflection. The second one has the free end reflection. Now the first we see the rigid or fixed end reflection. Let us consider a string. One end is fixed to a rigid support. See, let us consider this as a rigid support. What is considered as a rigid support? Now the string is one end is fixed. This is the one end is fixed to the support. The other end is plugged. See, the other end is plugged with hand. The transfer pulses are traveling the forward direction. When the crust is reaching, when the wire, the string can be vibrating, then here the transfer pulse are generated. This is called as a pulse. What is called this? Pulse. Pulse. What is the crust? This is called as a crust. Crust. The crust is reaching to the rigid supported. The crust is reaching to the rigid supported. This is called as the incident wave. Incident wave. Incident wave. This is the direction. And the transfer pulse are traveling forward direction. When the crust is reaching to the fixed end and return the back flow. And the return back is again is this same rigid supported. This is the return. When is the wave is return, but here is the wave is coming in downward. This is called the trough. And traveling, this is the direction. So this is called as the trough. Now this is reflected wave. Reflected wave. See, observing here. When the wave is instantly crushed on a rigid supported and reflected wave is in a trough is coming by. And now we are observing the phase difference. The phase difference between incident and reflected wave is 5 degrees. 5 degrees. See, this is the crust and the reflected wave is in a trough. This is called as a rigid or fixed end reflection. What is called as a rigid or fixed end reflection. The next we are discussing the free end reflection. Free end reflection. See here, the one end of the string is the fast end to a light ring. See, this is considered a rod. So what is considered as a rod? A rod. Now here is considered by a ring at the center. This is the ring. Now see, one end of the string is the fast end to a ring. This is the one end of the string is fast end to a ring. The transfer pulses are generated in a string if the crust is reaching the ring. And when this string is plugged, the string is plugged. So what is the here? This is the transfer waves are, the pulse are generating, transfer pulse are generating to this one. So this is the direction. So this is called as the incident wave. This is the fast end to a ring. And reaching to a crust. The crust is reaching to a fast end. And the reflected wave also crust. This is the reflected wave. Reflected wave. Now the reflected wave also is forming a crest. Now the instant is a crust and reflected wave is also the form of a crust. See, that is the ring is returned back to the same crust. The ring is returned back to the same crust. Therefore, the phase difference between incident and reflected wave is 2 pi. How much is here? 2 pi. Because of the crust and crust, how much of the angle is 360 degrees. And here the crust and trough have there is a 180 degrees. That is say the pi is denoted by this. called as the free end reflection. See, what is the difference of the fixed end reflection and free end reflection? Now observing for the both diagrams. But in fixed end reflection, if you have the one rigid support is there, but here the fast end of a ring is nothing but the small face is there. That is the difference. And here the angle is there by here the angle will be of the 2.